Good morning, afternoon, or evening. How are you doing today? Welcome back to Mr. Morrow's Algebra II class today. We're going to continue with systems, and we're going to be talking about solving systems with elimination. Remember that other than graphing, there are two other methods. There's two algebraic methods to solving systems. One of them we've already learned, substitution. That's when you solve for one variable, substitute it into the second equation, solve for the second variable, and then plug that back into the original equation to find the second variable. Today we're going to be talking about elimination. And I really like elimination, not only because it's easy, but for me it's easy to remember. Because when I think of eliminating, I'm getting rid of something. When, or think of it an elimination tournament. The loser gets eliminated. It's gone. Bye-bye. You don't have to worry about it anymore. Well, that's what happens here in elimination. There are several easy type of eliminations, and then some more complex ones. We're going to start, of course, with the easy ones. What is the solution of the system of equations? Okay, and you have 4x plus 2y equals 9, and you got negative 4x plus 3y equals 16. First of all, how do you know that I would even do elimination here? Why can't I solve for y? Well, you can. If you wanted to solve for y or x and do this through substitution, you are allowed. However, when they present you a problem in standard form like this, remember ax plus by equals c, you can try to eliminate one of the variables. So the first thing you want to check is line up the equation variable to variable and add the equations together, making sure that one of the variables is eliminated. So I have my x's with my x's, my y's with my y's, my constants with my constants. When I add these two together, my friends, what's 4x minus 4x? God, bye-bye. 5y equals 25. Divide by 5. I'm going fast because I know you know how to do this. Y equals 5. Now that y equals 5, step 2, substitute the value of the variable you just solved for in either of the given equations and solve for the other variable. So I'm going to choose to plug it into this one. So I got 4x plus 10, because 2 times 5 is 10, equals 9. 4x equals negative 1. X equals negative 1/4. So my solution is negative 1/4, comma 5. To me, this is the best. To me. That's me. Okay? I love this way. Whether you like it or not, unfortunately, there's going to be times where I'm going to say, solve this system by elimination, or solve this system by graphing, or solve this system by substitution. So you're going to have to know how to do them. But this is the easiest one for me, especially when it's already set up for you in standard form. Does that make sense, guys? Pretty simple, right? Now, the problem comes, not the problem, I shouldn't say that because this isn't a problem at all. The challenge comes here. What happens when they write the system in standard form? However, I don't have an easy elimination here. If I add these two together, I'm going to get 5x plus 12y. Did I eliminate anything? No. So we have a little bit of a different take on this one. Let's take a look at the steps. Number 1, sometimes you have equations that do not eliminate easily. In these cases, you need to line up the equations and create an equivalent system by multiplying each side of one or both equations in a system by the same non-zero number. What am I talking about? Let me explain. First of all, who do you want to get rid of? The x or the y? I don't care. Okay, x. All right, we'll do x. Some people said y, some people said x. It doesn't really matter. But I want to get rid of the x's. Okay, guys. What do I have to make this 2x, and what do I have to convert this 3x into so that they can eliminate? One of them has to become 6x and the other negative 6x? Fantastic. I don't care who you make negative 6x, by the way. I'm just choosing what I want to do. You can do either one of them negative. I want it to be clear. I'm choosing what I want to do. I'm going to choose to multiply the top by -3, and I'm going to choose to multiply the bottom by 2. Please remember that this is an equation. We're keeping equality. So we're multiplying on both sides of the equation to keep equality. So this top equation now becomes -6x minus 21y equals -12, plus this bottom equation is 6x plus 10y equals -10. The x's cancel out. That's exactly what I wanted. So I have -11y equals -22 divided by -11. Y equals 2. Nice. Now I can plug it into either one of the original equations. So I already did step 2, sorry. Step 2, line up the equations variable to variable and add the equations together, making sure that one of the variables is eliminated. We did that. Step 3, just like before, substitute the value of the variable you just solved for in either of the given equations and solve for the other variable. So me, I'm going to choose to plug it into here. It doesn't matter where you go though. So I got 2x plus 14 equals 4. Subtract 14 to both sides. 2x equals -10. Divide that bad boy by 2. X will equal -5. My solution, -5, comma 2. Easy peasy. Does that make sense, my brothers? Pretty simple, right? So if you see it in standard form, you're going to say, oh, I want to eliminate it. Sometimes, like I said, it's not going to be nice and easy Mickey Mouse. You can multiply, though, and make them into numbers that are going to eliminate, boom, like that. Sound good? May I continue? Okay. Let's do some examples because it's just the best way to do it. Let's see what happens here, guys. You're going to love this one. For sure, I'm going to do elimination. They're already in standard form. When I add them together, well, wait a second. I guess, wait a second. 0 equals 0? What happens there? Is that a true or false statement? True, so it's a true statement? All real numbers. That's exactly right. Sometimes people like the symbol. That's fine. Okay? What happens over here in example B where I've got an elimination, I got 0 equals 16. Is that a true statement? No. So what happens there? No solution for sure. Bless you, son. Okay, how about here? Wait a second, Moral. I can't eliminate anything here, man. What do I do? Am I stuck or what do I do? What do I do? Who do you want to get rid of, guys? X or Y? I don't care. X, okay. What do you want to multiply the top by? 2. What do you want to multiply the bottom by? 5. Remember, it's to both sides. So, first equation, 10x plus 8y equals 20. Second equation, -10x plus 15y equals 135, -135. Thank you. Cancel. I got 25y, right? Thank you. Pay attention, Moral. 23y equals -115. And then divide that by 23 to both sides. And if I'm not mistaken, y should equal -5. Is everyone with me? Now that y is -5, you can plug it into either equation. This time I'll let you guys choose. Who do you want me to plug it into? The first or the second? First one? You got it. So I got 5x minus 20, because 4 times -5 is -20, equals 10. Add the 20 to both sides. 5x equals 30. Excellent job, son. Divide by 5. X equals 6. My solution, 6, comma, -5. And of course, if I plug those into both of these equations, both equations will be true. Make sense? Now, with D, me personally, I would probably divide everything by 4 and use substitution. But I specifically want to practice elimination. So what do we have to do first here, my man? That's exactly right. We're going to have to put it in standard form. So this first equation, I'm going to add 6x to both sides, my brothers. So I got 6x plus 4y equals 30 plus my 7x plus 10y equals 35. Not a very pretty system. Who do you want to get rid of? Because I don't care. The y. Okay. What do you want to multiply the top by? By positive 10? Okay. That's okay. No. 10 works as well. Oh, yeah. You could have done 5 to make it 20. Do you want to do that instead? Okay. That is a much better route. And then the bottom you want to multiply by, not by 2, by negative 2. Okay, so top equation, 30x plus 20y equals 150. Second equation, negative 14x minus 20y equals negative 70. I've got 16x, the y's cancel, equals 80. Right? And then I'm going to divide by 16 on both sides. So x should equal 5. Now, who do you want to plug that into to solve for y? I would definitely use the top equation in this case. So I'm going to have 4y equals negative 30 plus 30. So that's 4y equals 0. Divide by 4, y equals 0. Bingo. My solution, 5, 0. Talk to me, my boys. Got this? Yes, sir. Please. Okay, eliminate by subtracting. Well, think about it. There is no subtraction anymore. When you're adding numbers, you're always adding numbers. They're either positive or negative. So, what my boy's question was, can I like distribute a negative to all of this? You can, but you're still adding in the end. You're just going to be adding integers. So you're doing double work. Okay? Thank you, son. Good question. Does that make sense, boys? All right. Carlos and Juan attend a baseball game with their kids. They get to the game early to watch batting practice and have a dinner. Juan says that he will buy dinner. He gets 7 hot dogs and 5 Pepsis for $38.25. After the 6th inning, everyone is hungry again. So Carlos buys 5 hot dogs and 4 Pepsis for $28.50. Find the price of each hot dog and each Pepsi. First things first, label, 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 label. Me, I'm going to say that the hot dogs equal X. And the Pepsis equal Y. Does it have to be that way? Could you have called hot dogs Y and Pepsi's X? Yes, I don't care. Just stay consistent. So, when Juan bought it, he purchased 7 hot dogs, 7X, plus 5 Pepsis, 5Y, for a total of $38.25. When Carlos purchased it, after the 6th inning, he purchased 5 hot dogs plus 4 Pepsis for $28.50. Before we go any further, does everyone see how I created that system? Because that's the hard part. After this, most people can solve it. But do you see how I created it? You promise? Okay. I'm going to cheat a little bit just for time. I'm going to use the calculator on some things. So I am cheating, but it's just for time. Who do you all want to get rid of? The y? Actually, I would agree with that in this case. What do you want to multiply the top by? 4. And the bottom? Negative 5. And remember, my brothers, it's to both sides. So equation 1 is going to read 28x plus 20y. Okay, this is what I wanted to do with the calculator. That's $1. 120. Is that 145? Wait, let me see. Let's see. 38.25 times 4. Wow. 153. I was off. Okay. And then at the second equation, I got negative 25x minus 20y equals 2850 times 5 is 142, negative 142.50. The y's cancel. I got 3x equals, that's going to be 1050, right? Yeah, 1050. Divide by 3. So x is going to equal 3.5. $3.50 per hot dog. Now, that's great. Awesome, Mr. Morrow. How on earth do I find now what my Pepsi costs? Plug it in, exactly. So I'm going to put it into the bottom one. 5 times 350 plus 4y equals 2850. That's 1750, right? 1750, so I'm going to subtract 1750 to both sides. I did do the math right there, right, guys? Yeah. 4y equals 11 bucks. 11 divided by 4. So y equals $2.75. Right? Yeah. So what's my solution? 350. Please put dollar signs for the hot dogs and comma 275 for the Pepsis. Mr. Morrow, you didn't label. Yes, I did. At the beginning, I said what x and y was. So as long as I write it as an ordered pair, I know what my x and y is. Does that make sense, my brothers? You promise me? Okay. Last one for this lesson, my brothers. At a fast food joint, 5 cheeseburgers and 3 medium shakes cost $15.50. At the same fast food joint, 3 cheeseburgers and 2 medium shakes cost $9.75. Find the cost of each cheeseburger and medium shake. Tell me, what do you guys want cheeseburgers to be? Okay, so I got cheeseburger. We're going to make that X. And I guess then shakes will be Y. Okay, what's the first equation, my brothers? Come on, you tell me. Yes, sir.
5x plus 3y equals 15.
5 cheeseburgers plus 3 shakes equals 1550. Thank you so much. That is perfect. What's my second equation, boys? Three cheeseburgers plus 2 shakes equals $9.75. Awesome. Okay, now Mickey Mouse time. Who y'all want to get rid of? Y. Okay. What do you want to multiply the top by? Oh, I shouldn't have done that. Sorry. By a 2 here, okay. And the bottom one? -3. Awesome. So I got 10x plus 6y plus, come on, Morrow, equals 31. Second equation, -9x minus 6y equals 9.75 times 3, 29.25. X, the cancels, the y's cancel, equals $1.75, right? Right? Yeah, 175. Perfect. So my cheeseburgers are $1.75. Now I gotta plug it in. So 3. I would go to the second one too. It's easier. 175 plus 2y equals 975. That's 3.75 times 3. That's 525. So I'm going to subtract 525 to both sides. I got 2y equals 4.5 divided by 2. Y will equal 2.75. $2.75. Did I mess up? Hold on. What did I mess up? Where did I mess up? Where? What did I do? What did I do wrong?
5 divided by 2.
Hold. Oh, sorry. Thank you. Brain fart. 2.25. Sorry. Thank you. So 175 for every cheeseburger and 225 for every shake. Does that make sense, y'all? Yes, sir. Thank you. Ye-
It's supposed to be negative and then the 9.
Yeah, it is negative. I did subtract it, though. That's why it's. Thank you for catching that. It is a negative. Thank you, my man. Thank you. Good boy. Does that make sense, my man?
Yes.
All right, brothers. We're going to move on. So you ready? All right, I'm just going to keep going. So this lesson will be a double lesson. I'll post it as that, okay? But that way we don't have to waste time. All right, so let's go to 4-6 now. Please and thank you. I'm going to pause it just so you can get your notes out. All right, let's do this, guys. 4-6, system of inequalities. By the way, don't freak out. I did this on purpose. I knew that you could handle these two. If you can graph an inequality, you can graph a system. In order to solve systems of linear inequalities, simply graph and shade each inequality individually. That's the key here. The area of the system which has overlapping solution sets are the solutions of the system of inequality. Let me explain. First things first, we know how to graph already, and we know that when we're graphing, we want to solve for y. So the first thing I'm going to do is I'm going to subtract x to both sides. So I've got y is greater than negative x plus 4. I'm going to go ahead and graph and shade that right now. My y-intercept is 4, and my slope is negative 1. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, go backwards, up 1 over 1, up 1 over 1. Is it going to be a dashed or solid line? Dashed. Am I going to shade above or below? Y is greater, right? So remember what I taught you guys. Do nice little neat shading like that. You're going to see why that's so important. Please do not go like this. Please. That works for an inequality, but it's not going to be very neat for the system. So for equation number 2, I'm going to subtract 3x to both sides, divide by 7. So y is going to be less than or equal to negative 3/7 x plus 3. I hope you guys all saw that, how I solved it. Okay, so my y-intercept is 3, and my slope is down 3 over 7. So down 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7. Let's go backwards. Up 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7. Shaded or dashed? I mean solid or dashed? Solid. I'm going to shave above or below. Now watch. You can go below here, right? But look, isn't this area here where you're overlapping? So this area right here, guys, that whole section are my possible solutions. Any point inside of this area, I'll highlight it just to make sure you really know what I'm talking about. Okay? Anything right here, in this area here, anything in there, those are going to be my solutions. Where they intersect. See how the blue and the red, they cross there? Guys, you see that? I'll make sure you understand this. That's literally it. Literally. And we're going to practice, of course. May I continue? Okay? Now, what is the solution set of the system? Sorry, let me just move this down a little bit. Sorry. All right, so same thing. Let's solve for y. I'm going to subtract 2x to both sides and divide by a negative. But what happens when I divide by a negative? What happens to the inequality sign? So remember, this should turn out to be y is less than or equal to 2x plus 3. Please do that. Make sure you got that. Make sure you guys understand that. And then the second one is already solved for you. So let's graph them, guys. 1, 2, 3, up 1, 2 over 1, up 1, 2 over 1, down 1, 2 over 1, down 1, 2 over 1. And that is less than or equal to. So it's going to be solid. And it's less than or equal to. So I'm going to shade below. I hope everyone's with me. If you want to do these, notice I do it in different colors. You can do it in different colors if you want, or you could just do it in the same color and just make sure you do your lines nice and neat. Y is greater than or equal to negative 1/2 x plus 1. So my y-intercept is 1. My slope is down 1 over 2. So down 1 over 1, 2, down 1 over 1, 2. What was that? Yeah, down 1 over 1, 2. Let's go backwards. Up 1 over 1, 2, up 1 over 1, 2. And that is greater than or equal to, so it's solid. And it's greater than or equal to, so right above. Guys, why didn't I even bother shading here? It's not going to be a solution, right? Whoa. So I just stick to where I'm going to have my solution. Now, what's my solution, Mr. Moore? You literally go like this, point, and you put solutions. Literally. Any point inside of here, any of these points, any of these will be solutions, I promise. Make sense? Easy, right? Told you guys. Sir. Fantastic question. My boy asked, since these are both solid lines, even the points on the line will be solutions? Yes. Will they be solutions if it was a dashed line, though? No. Great question, son. Thank you. Does that make sense? All right, let's keep going. This one was nice and easy. I already gave it to you. Both solve for y. Let's see what we got. Y is greater than or equal to 3x minus 5. So my y-intercept, 1, 2, 3, 4, negative 5. My slope, up 1, 2, 3 over 1, up 1, 2, 3 over 1, down 1, 2, 3 over 1, 2, 3 over 1. It's going to be a solid line because greater than or equal to, and it's greater than. So am I going to shade above or below? Above. Very good. Notice I try to be as neat as possible. And this time I'll do it in the same color so you can still see the solution very clearly. Y is less than or equal to negative 2x plus 5. So I go 1, 2, 3, 4, 5. Down 1, 2 over 1. Down 1, 2 over 1. Down 1, 2 over 1. Solid because it's less than or equal to. But am I going to shade above or below? Below. So look, this is where it's coming. You see how the checker pattern lets you know where the solution is? Do I have to continue over here? No. Why? Because that's not going to be part of the solution, guys. You're just wasting time. Can you do it if you want to? Sure. But is that going to be part of your solution? No. What is your solution? Everything encapsulated inside of here, guys. Those are your solutions. Infinite amount of solutions. Sir, thank you. I'm sorry, my man? I'm telling you, you would answer it just like this on a test. That's exactly what I told you to do, my man. I promise. I'm not going to change the game on you on the test, I promise. Thank you, sir, for verifying. And again, if I said to you now, give me one solution. What's one solution from here, guys? Go, name a point. 0, 0. Great. 0, 2. Negative 1, 2, 3, 4, 4, 2. Any point inside of here, any point is a solution. Does it make sense? Thank you. What is the solution of this system? Okay, let's see. Let's first solve for y. Y is going to be less than negative 2x plus 7. And this bad boy, y is going to be less than, because I have to divide by a negative, so I got to flip the inequality, less than 7 halves x minus 2. So let's first graph my first one. Y is less than negative 2x plus 7. 1, 2, 3, 4, 5, 6, 7 is my y-intercept. Down 1, 2 over 1. Down 1, 2 over 1. Down 1, 2 over 1. Up 1, 2 over 1. Dashed line. Less than So you shade below. And then y is less than 7/2 x minus 2. Y-intercept is negative 2. Slope is 7/2. Up 1, 2, 3, 4, 5, 6, 7. 1, 2. 1, 2, 3, 4, 5, 6, 7 will be about here. 1, 2 about there. Dash line again. And it's less than, so I'm shading again below, right? Below. So that's here. So what's my solution? This area right here. These are my solutions. And again, in case you don't see that, it's this area in blue. All of that are your solutions. Making sense, my brothers? Awesome, you rule. Okay, this one I do always because a lot of people forget, they get confused. What kind of a line is a y equals, guys? Horizontal, very good. So this y is less than or equal to 5. So you go 1, 2, 3, 4, 5. Solid line because it's less than or equal to. So now in this case, I'm going to shade above or below? Below, yeah, it's less than. And then I have x is greater than negative 3. So what kind of a line is an x equals equation? Vertical. So I go 1, 2, negative 3. Dash line. Because it's just a greater than. So am I going to go to the right or to the left? To the right because it's greater than. You could go up here, but that's not the solution. Oh, but look here. Where do you get the checkerboard pattern? Right there. So this part here, all of this, those are your solutions. Sir, the solutions on the x line? Oh, on the actual x, that will not be a solution. Correct, sir. Negative 3 will never be part of the solution set because it's greater than negative 3. Thank you, sir. Thank you. Now, I know what you're worried about, word problems. I got an easy way for word problems. Easy way. If you guys believe in me, I promise you, I won't make it that bad. Your city's cultural center is sponsoring a concert to raise at least $30,000 for the city's youth services. Tickets are $20 for the balcony seats and $30 for the orchestra seats. If the center has 500 orchestra seats, how many of each type of seat must be sold? Okay, I think I messed up here. Give me 1 second. Okay, guys, I did mess up. I'm sorry. I didn't tell you how many balcony seats. Let's say that there are, this is probably going to get really ugly now, so I'm sorry. But let's just say that balcony seats are 300, okay? 300 seats. So now I have, okay, 20, blah, blah, blah. Okay, so I know I'm going to call X my orchestra, right? And my Y, my balcony, right? So together, my orchestra seats plus my balcony seats will equal 800 seats, right? You guys with me? And then I have $20 per balcony. So I had said Y is balcony, so 20Y plus 30 for each orchestra. So 30X will equal $30,000. Now, what I do? I'm sorry. And this can be less than or equal to, and at least greater than or equal to. Okay? Sorry about that. Does that make sense? Because you have to have less than or equal to 800 seats because there's no more. And you want to make more than 30,000, right? Now, Do not solve for y. Because you're going to have a mission. Think about it. Give me 1 second. All right, boys. So like I said, if you wanted to, you could go ahead and solve for y, but that's going to be a mission to graph. So I make your graphing for this very simple. I want the concepts. Let's be honest. If you're running a business and you're putting this into your business, I promise you, a computer would graph it for you. So you may be asking, okay, great. Why are we learning it then? Don't you want to have an idea at least of what the graph should look like? Or do you just want to depend on what maybe the programmer messed up when he wrote the program? And you think you're doing great and you're really losing money because you don't have an idea of the concept. So this is what I'm going to do, guys. I'm going to make my life extremely easy. Like, extremely easy. I'm going to start with this guy because there's larger numbers. When y is 0, the x-intercept is 10,000, right? Right, guys? So I'm going to go by thousands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. 10K. My y-intercept, when x is 0, is 15,000, correct? It's 1,000. Maybe I should learn how to do math. Wow, epically embarrassed. Thank you. So it's 1,000. So let's go by hundreds then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hundreds. So that's 1,000. Thank you, sir. Okay, I didn't mess up, right? Yeah, okay. Now when I divide by 20, it's 1,500, correct? So let's go by I don't know. Let's go by hundreds there too. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 1,500. Okay, ready? Here we go. It's going to be a solid line. Now, if I were to move the x over, is the y going to be greater than or less than? If I were to solve for y here, guys, be greater, right? So you're going to shade above. Now, the next guy. I've got my y-intercept is 800, and my x-intercept is 800, correct? So 1, 2, 3, 4, 5, 6, 7, 800. Wait, what did I do wrong here? And this is 1, 2, 3, 4, 5, 6, 7, 800. And then this is less than. Wait, I did something wrong here. What did I do wrong here? I want to make at least that's greater than or equal to. And then my tickets are 20 and 30. Yeah, I got that. And I got a shade less than. Wow, so there would be no solution for this. That's a horrible problem. That was horrible. That doesn't teach anything. That's horrible. I may have worded this wrong here, guys. I'm going to have to come back to and look at the numbers. I'm sorry. Let's look at the next one real quick. Sorry about that. That was kind of bad. And I apologize. Real quick. Come on now. All right. Holy moly. Okay. Here we go. A pizza parlor charges $1 for vegetable topping. Please don't get ready yet. And $2 for each meat topping. You want at least 5 toppings on your pizza. You have $10 to spend on toppings. How many of each type of topping can you get on your pizza? Okay, well, let's call it. Okay. I don't know why this is happening right now. I don't know why this is happening. Let's. Okay. Let me pause this for a second.